Have you ever opened a PC and looked inside and thought, CPU, GPU, RAM, SSD, PSU? It can look like a confusing pile of parts, and every component seems to have some complicated name. But here's the good news. You don't need a tech degree to understand how a PC works. In this video, I'm going to explain the most important PC components. By the end of this video, you'll know what every major part does and how all of them work together. 1. CPU, the brain of the PC. Let's start with the CPU, or Central Processing Unit. Think of the CPU as the brain of your computer. Whenever you open an application, type something on your keyboard, run a calculation, or give your computer a command, the CPU processes those instructions. A CPU has cores. You can think of each core as a worker. A 4-core CPU has 4 workers, while an 8-core CPU has 8 workers that can handle different tasks at the same time. Then there's clock speed, usually measured in gigahertz or gigahertz. In simple terms, clock speed tells you how quickly the CPU can process individual cycles. But remember, you can't judge a CPU by core count or gigahertz alone. Modern CPUs have different architectures and designs, so 2 processors with the same number of cores can perform very differently. So the simple way to remember it is, the CPU is the brain that processes instructions. But the CPU needs somewhere to keep the information it's currently working with. That's where RAM comes in. Number 2. RAM, your PC's short-term memory. RAM stands for Random Access Memory. The easiest way to understand RAM is to imagine a desk. Your CPU is the worker sitting at the desk. When you're working, you put the files and tools you currently need on the desk so you can access them quickly. RAM works in a similar way. Your open applications, browser tabs, games, and files you're currently using need RAM. That's why having more RAM allows your computer to handle more tasks at the same time. For example, a PC with 8 GB of RAM may start feeling limited when you have lots of applications and browser tabs open. A system with 16 GB gives you more room to work. But here's something important. RAM is not permanent storage. When you shut down your computer, the information stored in RAM disappears. So if RAM is your desk, where does your permanent data live? That's the job of storage. Number 3. SSD and HDD long-term storage. Your storage drive is where your files actually live. Think of RAM as your desk and storage as your filing cabinet. Your photos, videos, games, applications, documents, and operating system are stored here even when your PC is turned off. There are 2 common types of storage, HDD and SSD. An HDD, or hard disk drive, uses spinning magnetic disks to store data. It's usually cheaper and can offer lots of storage for the money, but it's slower and has moving parts. An SSD, or solid-state drive, has no spinning disk. It uses flash memory, which allows it to access data much faster. That's why a computer with an SSD can usually boot Windows and open applications much faster than one using an old HDD. If your computer still uses an HDD as its main drive, upgrading to an SSD can make a huge difference in everyday responsiveness. So remember, RAM is temporary workspace. Storage is permanent memory. 4. GPU. The artist? Now let's talk about the GPU, or Graphics Processing Unit. If the CPU is the brain, the GPU is the artist. Its main job is to process and render graphics. When you're playing a game, watching video, editing footage, or working with 3D graphics, the GPU can handle huge numbers of visual calculations. Here's an easy way to understand the difference. Imagine the CPU has a small group of highly skilled workers. The GPU has a massive team of workers, each designed to perform lots of similar calculations at the same time. That's why GPUs are so good at graphics and other highly parallel workloads. And no, GPUs aren't only for gamers. They're also used for video editing, 3D rendering, AI workloads, scientific computing, and other demanding tasks. Some computers have a dedicated graphics card, while others use graphics built into the CPU. 5. Motherboard, the connection hub. Think of it as the roads of your PC. The CPU, RAM, GPU, and storage all connect to it and communicate through it. It also determines which CPU, RAM, storage, and other components your PC can support. So, the motherboard is basically the foundation that connects the whole team. 6. PSU, the power source. The PSU, or power supply unit, provides power to all the components. Think of it as the power station of your PC. It converts electricity from the wall into the power your computer needs. The CPU needs power. The GPU needs power. The motherboard needs power. Storage and cooling fans need power too. A PSU doesn't make your PC faster, but a good quality one provides stable power and helps protect your components. 7. Cooling. Keeping things cool. Every component produces heat, and too much heat can reduce performance. That's why PCs need cooling. Most computers use fans and heat sinks, while some powerful systems use liquid cooling. For most people, good air cooling is enough. And don't forget to clean out dust, because blocked airflow can make your PC run hotter. 8. PC case, the home. Think of the case as the house that protects the entire team. It holds your components in place, protects them from physical damage, and helps control airflow. A well-designed case allows cool air to enter and hot air to leave. A poorly ventilated case can trap heat inside. So the case isn't just about RGB lights and appearance. Airflow, component compatibility, cable management, and available space all matter. 9. The supporting parts. There are also several smaller components that help complete the system. Your keyboard, mouse, and monitor are called peripherals. They allow you to interact with your computer and see the results. Case fans move air through the system. A network adapter provides wired or wireless network connectivity. Thermal paste sits between a processor and its cooler and helps transfer heat efficiently. And the audio hardware handles sound. On modern PCs, audio is usually integrated into the motherboard rather than being a separate sound card. These parts may not get as much attention, but they all have a role. 10. The most important concept, bottlenecks. Now that you know the main components, there's one concept you absolutely need to understand, bottlenecks. A common beginner mistake is thinking, if I buy the most expensive CPU, my PC will automatically be fast. That's not how computers work. Your components need to work together. Imagine putting a powerful graphics card with an underpowered processor in a system that heavily depends on the CPU. The GPU may be capable of doing much more, but the CPU could limit overall performance. Or imagine having a powerful CPU, but an old, slow storage drive. The processor can work quickly, but it may spend time waiting for data. That's a bottleneck. The goal isn't to buy the most expensive component. The goal is to build a balanced system for what you actually do. How everything works together. The CPU processes instructions. RAM holds the information you're currently using. The SSD loads your files and programs. The GPU handles graphics. The motherboard connects everything. The PSU provides power. Cooling controls the temperature. And the case protects the entire system. So a PC isn't just a random pile of parts. It's a team where every component has a specific job. And once you understand that, PC hardware becomes much easier to understand. If this video helped you, hit like, subscribe, and let me know in the comments which PC component you want me to explain next.